Welcome in my talk, The Future of Java on the Raspberry Pi here at FOSDEM. Happy to be here at this virtual conference. A bit strange times, but happy that we still can share all these Java goodies. Let me introduce myself. I'm Frank Delporte. I live in Belgium. I do a lot of blogging on webtechie.be on my own blog and also on Foojay. And I've been programming since I was 10 years old, a long time ago. And it all started with this Commodore 64, which was a great device and allowed me to already start with electronics and connect, for instance, my Lego trains with this Commodore so I could control my Lego train. I'm working at Toady as a software developer, but most of the knowledge I have about embedded and Raspberry Pi and Arduino actually comes from Coder Dojo, a computer club, where we teach kids to work with computers, to program, to present what they've done, to work together, to think about ideas and how to solve certain problems. And the coaches at Coder Dojo bring their own knowledge to these events. And that's where I first learned about Raspberry Pi and Arduino and this amazing hardware at a very low price, which allows you to do a lot of great stuff. And because I love Java, I combined all this because I wanted to create a drum boot for my son. Um, and you see it has a touchscreen. It is controlled by a Raspberry Pi and Arduino for the LED strips. And he can control different devices on 220 volts. So this was actually my first Raspberry Pi project where I wanted to use Java and JavaFX. And this all led to this book where I describe my whole journey, what I learned doing all this, how I started with installing JavaFX on a Raspberry Pi, how the pins work, where you connect the electronic components, build, for instance, this small chart to show a temperature measurement or control an 8x8 LED matrix. All very cheap electronics components that you can use on the Raspberry Pi and which you can control with Java, like for instance getting the weather forecast from an API and show it on a small display. Also Spring works on the Raspberry Pi, of course, and it allows you to build REST services to control the LEDs or read the button state or store data. And then of course you have this application that I used in the drum boot of my son to control a LED strip, and here it even uses a queue and an Arduino to connect multiple devices like a PC and a Raspberry Pi and an Arduino and all share the same data. And as Java community is a great community with a lot of great people who are very open to communicate and to discuss certain topics, I also have a lot of interviews in the book. And of course, the code is shared on GitHub. Now, to get to the start, what is a Raspberry Pi? It's a very small PC. Everything is here. You have only have to connect a screen and a monitor and a mouse. And you can get started. You pop in an SD card with the operating system of your choice and you can get started. There are different types of these boards. The B is the most used one, and it ranges from 40 till 80 euros depending on the amount of memory you want to use on the board. And you have also some special versions of it or smaller depending on the use case. In 2020, they launched a new compute module, and the idea of the compute module is that you embed it into your own projects with the hardware that you design around it. So the board, the compute module has all the logic and the memory, and then you design a base board with all the peripherals and the connections you really need. And you can buy a compute module base board for your experiments and then later replace it with your own version. Also last year they announced the Raspberry Pi 400, which actually is a keyboard with a Raspberry Pi 4 inside it, and you see that you also have the connections similar to the Raspberry Pi 4 here. So it's the same Raspberry Pi with the different form factor integrated in a keyboard. And yeah, this let me think, where did we see this before? Indeed, that was the same form factor of the first PC I used, also with a connector on the back to connect peripherals. The only difference, if you compare it to the cost at the current prices, is that the Raspberry Pi 400 is 14 times cheaper than what you paid so many years ago for the Commodore 64, and it's very, very powerful. Because just to compare the screen, this is what I was programming in on the Commodore 64, and this is what I'm programming with the Raspberry Pi 4. A 4K display attached to it. I have two Visual Studio Codes open. This is a screenshot while I was writing my book. So you can do a lot of real programming on a very cheap PC. A question I get asked a lot is, why would you use Java on a Raspberry Pi? Wasn't it designed for Python? Well, actually, yes, it was. When they designed the board, they were looking for a fruity name. That's where the Raspberry Pi comes from. And they added Pi from the Python language that they were using at that time, also from the NumberPy, of course. But it could also have been the Raspberry Java or something like that, because Java works just as well. And definitely now that Java is evolving so fast with all these releases every 6 months, a lot of improvements get added, but also features which make it more powerful to use it on a Raspberry Pi or other cheap electronic components. And even Oracle thought this is a match made in heaven. I wrote an article for the Oracle Java newsletter describing a first project you can make on a Raspberry Pi with some electronic components and all the code, of course. And it was one of the most liked and retweeted tweets of last summer, because indeed this cheap hardware allows a lot of new people to get into programming and use the language of their choice on any platform. Now, if you start with a new Raspberry Pi board and you flash an operating system to an SD card, you can download it from the Raspberry Pi website with their Imager tool, and it's a full Linux system based on Debian 32-bit. And if you go for the full version, you have OpenJDK 11 pre-installed on it, so you can immediately start with any Java project. There is so it also included in this full Raspbian OS or Raspberry Pi OS, as it's rebranded only recently. You see that there is a lot of tools pre-installed, not Visual Studio Code, but you can install it from their website. There is a version available built for the Raspberry Pi and the ARM processor, and there is also a 64-bit version, because there is already a proof of concept work in progress version of that operating system for 64 bits, as the processor allows it. If you install Visual Studio Code and the Java extension pack, which all runs without any issue on the Raspberry Pi, you can make any Java application on this board. So as I said, Java is pre-installed. So if you power your Pi for the first time and you do a Java version request, you will see that you have version 11 there available. If you want to use JavaFX, if you want to make a user interface, you have two choices. Either you select JDK, which has JavaFX included, as it's no longer included since Java 11. But some of the JDK providers have versions where JavaFX is integrated. Again, Liberica from Bell Software is one choice. And it's the approach I took in the book, because it allows you to test and develop very easily without any extra configurations. So it's just downloading the JDK from their website, configure it, and then you see, for instance, that this is version 13 from Bellsoft. But there's also another approach, of course, because JavaFX is a standalone project. It has the same release cycle as Java, so 2 new versions each year, and it's all powered by Gluon, who maintain this project, and they also provide the build versions. So you can find on their website an OpenJFX version, also again specifically for the Raspberry Pi. The only thing you need to do then is either configure it in your EDA and on the Raspberry Pi, give some additional startup commands if you start your application. But this allows you to use the latest features which are added by Gluon and the community in this OpenJFX project. So for instance, if you look into the screenshot, that's JavaFX 16 running on the Raspberry Pi with Java 11. So you can combine these without any problems. There is no dependency between the latest JFX and a later Java JDK. They can live on their own, and you can use the version that you want. And the latest versions of JavaFX have specific Raspberry Pi improvements for direct rendering on the screen, and have a much more smoother playback, for instance. If you look at this example, which is a video from Gerrit Grunwald, who created this BaseFX game. So yes, indeed, it's a JavaFX game, and it's running on the Raspberry Pi at 60, almost 60 frames per second. You see, it's very, very, very smooth. I've done some experiments myself. One of them is with JavaFX 3D. It was something really new for me. I never used it before. This is one of the very first examples used to demonstrate JavaFX 3D many years ago. And you see that it runs very smooth. So it's an application which draws a molecule, and you can control it with some keys. And this is running on a Raspberry Pi, of course. Another example is with FXGL, which is a gaming engine that you can use inside JavaFX to build games. And I've used this just for some kind of performance test. So you have 30 dots moving at a random interval and random location, and without any improvements within the FXGL project yet, we already have this 30 frames per second for very smooth animations, and also there is some improvements ongoing. Now, an additional feature of the Raspberry Pi is, of course, the header. These 40 pins where you can connect hardware like LEDs and buttons, but also a lot more complicated devices. To know what's inside these headers, I created a small Java library, which you can find in the Maven repository, which explains where the pins are located. And with JavaFX, I created this small demo application. So, for instance, the latest Raspberry Pis, they have a 40 pin header, and here you see it visualized. What output they have, for instance, a 3.3 volt or a 5 volt, or they are a ground, or they have or a GPIO, and a GPIO is to connect your devices, and which numbers then to use into your program. And some of these pins have specific functions, so all this is explained here or visualized, and you can find it very easily what you can use them for. So a GPIO, it's a 1 or a 0, it's a true or a false if you look into coding. But for electronics, that means it's a 3.3 volt on the Raspberry Pi if it's a 1, or a 0 is 0 volt, meaning a high or low state for electronics, or an on or off for a LED. And as you can see, there are some very handy extensions boards that you can stack on top of these pins, also again to find back the right number to use into your program. And on these pins you can connect any kind of devices. The easy ones are a LED and a button, but of course you can go a lot further and control a chip for a LED number, or an 8x8 LED matrix, or serial communication. There are different types of communication protocols available that you can use to control this electronics. Now let's look into a simple experiment where we have this button and a LED. So we connect the LED to one of the GPIOs to put it on and off, and we connect a button to read the state if it's pressed or if it's not pressed. By the way, as you've seen in this wiring diagram, there is a resistor connected to the LED because the output is 3.3, but the LED normally has a lower, or needs a lower voltage, or otherwise you burn it. So that's where we have this resistor for. And there is an app for that, of course, to calculate which resistor to use. And one of these apps was created by me together with Gluon, just to show you how you can create a mobile application with JavaFX and use GitHub Actions to make an executable out of it, a native executable using GraalVM for all operating systems, being Windows, Mac, Linux, just an application, and then apps for the App Store for Google and Apple. And they are all built on GitHub with Actions and even pushed to the App Stores. It's not part of this presentation, but you can read all about it on my blog or on Foojay. And all the code is, of course, available and shared on GitHub to show you how easy this is to do. Now we've seen that we in this wiring diagram that we have connected a LED. Now the LED is connected to GPIO 22 and the button is connected to GPIO 24. And now we can start using them and control them from our Raspberry Pi. This is how it looks with some breadboards, which are very easy if you start experimenting with electronics to set up an experiment very easy and fast. Now, first we're going to test if this works from the terminal. We can just toggle, configure one of the GPIOs to be an out mode, and then we can send a 1 or a 0 and toggle this LED. And you see this is very easy to do from the terminal, of course, and we can also do the same with the button, and we can read the state of the button. So we say that we want to use this GPIO as an input pin, and then we can read it, and it's a 0 when it's not pressed, and as soon as we press it and we read it again, it is a 1. Now, if you want to do this from Java, we can take the easy approach and the dumb approach, let's say, and just use Java. No dependencies, no imports. We're just gonna reuse that terminal command that we've just seen and execute it from Java, and that's something we can do with runtime exec. And as you can see in this code, so we just say we want to have this GPIO mode 3 as an output pin, and then we toggle it on and off 10 times in this loop, and then we have this very simple Java code. Now, because we have Java 11 pre-installed on our Raspberry Pi, we don't need to compile it. So we have this script here, and we can just run it with Java. So if we run Java with this Java file, in the background it actually will compile it, I think, but we just give the Java file, we wait a little bit, and then we get the result of this application. And as you see and expected, this LED turns on and off. Okay, now let's make this a real Java project, a Maven project even, and include Py4j. Py4j is a library to connect these GPIOs to software, to Java software. So it's either it's on one side, it's a library which integrates into your Java application, and it uses native libraries to interface with the hardware and give you access to all these communication protocols and what you can do with these pins. Now, there is a Py4j version already existing for a long time, and the latest one was 1.2, which was released in 2019. But since then, a lot has evolved because we had the new Raspberry Pi versions and then some changes in the native libraries. So there are some changes scheduled. So there will be a version 1.3 and 1.4 which support Java 8 and Java 11. But there are some problems with this project. On one side, there is a lot of device support included in this project, which makes it very difficult to maintain and to release new versions and to test all the features. And maybe the biggest problem is the wiring Pi, this native library which is used to control these GPIOs. It has been deprecated last year. And there were also a lot of confusions when people started using this library, because wiring pi uses another numbering for these GPIO pins than most other libraries and projects where you have the BCM numbering. You can use them, but it caused a lot of confusion. Now let's look at some of the codes if you're still using this version of Py4j. It's very easy just to initiate a controller, and then let is just provision an output pin, give it the right pin number, give it a name, and then you can just turn a LED on and off, high and low, with some commands. And something similar can be done with a button, and then we can give it a change event listener. So we are really coming into the Java code and how we are used to do Java. And a change event listener can then do something with the events when the button is pressed or released. And in this case, we are just storing when a button was pressed. Now, if you then look into this project, and this is the project which was also fully described in the Oracle Java newsletter, you can see that you from the screen can toggle this LED. If you read the button or click the button, then you see on the lower graph that a line is drawn, because we just store the timestamps when the button is stored. And we even have another distance sensor attached to this Raspberry Pi, and you see in the upper chart that every second the distance is measured and visualized also in a graph. So this is a very basic example to show you how to use Py4j. And it's a touchscreen, by the way, so you can also do it from the screen itself. Now, what's the future for Py4j? And that's something something where we're very looking forward to. It's a version 2, a complete rewritten and redesigned architecture of this framework, which is fully Java 11 modular. And it will support all Raspberry Pi boards, because there is a new native library being used. It's PyGPIO instead of wiring Pi, which is not deprecated, of course, very well maintained, and has a large community behind it. And there was also a choice made to reduce the code base and remove all this device support and the example projects. They are now on GitHub as separate projects, which will make it a lot more easy to extend this library, maintain it, test it, and then have these separate projects and examples live on their own, and they can have their own release cycle if something has to be changed in there. But it's work in progress, and it's definitely something we want to push forward in 2021 and make a first release of it. But it's already there. You can already start using it. So you already have this website which fully describes it. We are working on the examples. And about this PyGPIO, so it's a new native library being used, and also this library is replaceable again, as it is a module inside the project, and it uses also the broadcast numbering, so removing this confusion of the numbering schemes. This is the architecture of the Py4j version 2 library, where you see that everything becomes a module, is separated, and we make it a lot more clear to maintain, and also people who want to join this project can find very easily where they want to modify or fix something. Again, let's show you a minimal example with the same thing, a button and a LED. This is fully described on this version 2 website. Initializing Py4j version 2 is creating a new auto context. This will automatically detect which platform you're using, which provider is available. There are other initializers available where you can configure more yourself, but this will be the perfect starting point for every new project. And a button, for instance, an input, it's a bit a different way of configuring it, but it's also the the more modern approach of Java and how you define objects and configure objects. Again, here we have a listener, and in this case, the listener just has a counter for the number of times a button is pressed. A let, same way is configuring with all the options you need in your use case. And in this case, we toggle it between let high and low on a different speed depending on the number of press counts. So, and then because this is using Java 11 and the modular approach, if you package such a project, you get a distribution directory with all the modules that you need for your project, which makes it very easy to install it on a Raspberry Pi and only update those modules that you are changing during the lifetime of your project. And our Maven configuration will also add a run script for you that you have everything available to just start it. So if you want to get started and experiment with this, you have this GitHub project, the Py4j minimal example. You can just clone it, build it on your Raspberry Pi and run it. And if you have connected the hardware as in the diagram, you will see them blinking LED and can read the button. Now, what did we learn is that Java and JavaFX on the Raspberry Pi, they just work. I find JavaFX a really amazing tool to build user interfaces, which are great looking, easy to configure, easy to extend, easy to program, and of course, easy to combine with electronics. And that's where the fun starts if you combine this with your Java knowledge and you want to learn more about this electronics, or maybe you're an electronics expert and want to start doing some software with it, then this is a great starting point. And as always with Java, by selecting the right dependencies and using existing projects and libraries, you can create amazing applications with minimal code. And there is a lot to look forward to. So we have this native support. Graal VM is also coming to the Raspberry Pi to 32-bit. We have this version 2 coming of Py4j, which will make it even more easy to have Java and electronics combined. We have JavaFX evolving a lot and being very performant and fast on the Raspberry Pi. Now, what's next? If you want to learn more, visit the Py4j website. My blog, Foojay, of course, has a full category for the Raspberry Pi. And of course, build, experiment, and have fun. That's only one thing I can advise you to do. If there are questions, I'm here in the chat to answer them. If you do some experiments and want to share them, tweet them send them on Twitter with the hashtag Java on Raspberry Pi. And if you want to read more, visit my blog, Foojay, or the book. Thanks a lot and have fun.